Physical evidence, identification, and comparison. The process of determining a substance's physical or chemical identity is the process of identifying evidence, identifying what that piece of evidence really is and really what it is made of. This requires the adoption of testing procedures that create characteristic results for specific materials. It needs to give results that indicate one specific material and not to other materials that may appear similar and can help rule out one material versus others. This type of test must be sufficiently rigorous and specific to exclude other materials. There needs to be a reference database for individual material identification. You need to have some sort of master database, ideally, against which you can compare your results so that you know that what you got was at least run appropriately. Identification may be the result of one test or multiple tests on the same thing. Oftentimes, in order to identify what a material is, you're not going to just do one thing to it. You'll do a few things to it, look at all of the results, and as long as all of those different test results point to something being of the same material, then you can feel reasonably assured that you are in fact working with the material you thought you were working with. The test should be flexible enough to require less than pristine materials. All the evidence that you're getting in the field is going to be non-sterile. They're all going to be contaminated with something, with other evidence, with dust, with dirt, with debris, with DNA other than the DNA you're looking for. Your tests should be able to take in that whole piece, that whole item, or at least that whole chunk of material, and still be able to run the test despite some low level of contamination. Remember, most evidence items are made up of multiple materials, and so there's a lot of different ways that you could go towards characterizing that. The gold standard for determining what something is to have a standard reference sample. This is a piece of physical evidence whose origin is known. A standard reference sample needs to be obtained from an ideally uninvolved place of the same thing that evidence could have came from. So you have a car that was in a collision with a wall. You have some of the car's paint on the wall and some of the wall's paint on the car. You want to make sure that the paint you found on the wall did in fact come from this car, and make sure that the paint on this car did in fact come from the wall. That's going to help establish a collision. Now you're going to need to test the paint chip from this part of the car, and you're going to need to take a sample from the wall somewhere other than where the collision happened. This is going to represent an uncontaminated sample. It'll be contaminated with environmental debris, but at least it ought not to be contaminated with stuff from the car. And the same thing the other way. With the car, you're going to want to take, a piece of paint from here to make sure that the paint you found on the wall is in fact the same as came from the car. In a comparison analysis, you're comparing a material against a standard reference sample. The suspect material is subject to a given testing protocol. The standard reference sample is also subjected to the same testing protocol. You're not going to do one test on the suspect material and a different test on the standard reference material. That doesn't make sense. Presumably they're the same item or the same material. Why are you doing two different tests on what you think is the same material? Do the same test on both. That way, if they both come out the same way, you can be reasonably assured that there is a chance that they are the same thing. Do the results match? If yes, then possibly it's a match of materials. If no, then definitely not a match. If you do the same test to two different materials and they come out the same way, they could be from the same place. You're not guaranteed that that's the case. as we'll talk about soon, a great deal of the materials we find in the world have been mass manufactured. So the paint on a Ford F-150 from, I don't know, cars, 2009, a cherry red Ford F-150 from 2009 is painted with the exact same set of paints as every other cherry red Ford F-150 from 2009. At least they came out of that plant. So it means it could be a match, but not necessarily. If you test both of those samples and they don't match, then you can be very certain, 99% certain, that they don't in fact match. If they came from the same place and were subjected to the same testing protocol, there's no reason that they shouldn't match. You need to choose what aspects of evidence to test. So most things are made up of a combination of materials. You're not going to disassemble that whole pickup truck that was involved in the car accident and compare every single part of the car. You're going to compare, though, as many different parts of that truck that were involved in the accident that may have resulted in the cross transfer of evidence, and that stand a chance at coming out with a reasonably individual profile that could be cross-referenced. The degree of agreement required can vary. You don't always need a perfect match, but you always need at least a close match for things to be considered a match. Depending on how specific the testing procedure is, you may end up with extremely specific results, and in that case, you do need close to a perfect match. Some tests are a little less sensitive than others. For those, a positive is a positive is a positive, and there's all kinds of shades of gray in between. Complete agreement does not automatically mean a definitive match. We've already discussed that.